All right, welcome to Circles. I'm starting you off with a long video. Sorry, but there's a ton of information in here and a lot of examples that I kind of wanted to go through. So most of these, I'm going to fly through these ones. Radius, radius is from the center to the circle. So like AR, diameter is the full distance, but it has to be through the center. Like AC, this is not a diameter over here, DF. It does not go through the center. So AC is a diameter. Circumference, that's the distance around the circle. So usually we do distance of a segment. Well, this is distance around the circle. It has its own formula. So circumference is diameter times pi. Some of you guys have heard pi r times 2, whatever. It's the same thing. So I just like to say diameter pi. So circumference is diameter times pi. I threw this one in here just because we're on circles, and you might see area, which is pi r squared. So pi times radius squared. A chord, this is where it gets new. So you may or may not know what a chord is. So a chord, line from one part of the circle to the other, but it's not through the center. So a chord is something like DF. It does not go through the center, and it starts at one point of the circle and goes to another point of the circle. Okay, also there's something called an arc. So it's part of the circumference. So like this little piece right here, arc CB, that would be an arc. So we've got a couple different types of arcs. We've got minor arcs and major arcs. So a minor arc is less than 180 degrees, and it only uses 2 letters, like I was saying right here. So this is an arc, and it's minor because it's less than half the circle. So the way they would write it would be like this, arc CB. So you have that little arc right above it. That's your notation. A major arc is more than half the circle. That will use 3 letters. So in other words, if I did a major arc, let me actually use a major arc from this one. So I could use something like CB, and go all the way up to D. So you just need to make sure that C is at the beginning and D is at the end. So it doesn't matter whether you choose A or B, but that's a major arc because it's more than half the circle. This is half the circle right here. So from C to B to A, that would be half the circle. More than 180, we had to go a little further. Okay, so a major arc uses 3 letters. Make sure you use the beginning and the ending, and you need to pick one in the middle. So it would be arc CBD. That's how that one would look. Okay, and then a semicircle. I'm sure you've heard that word before. A semicircle is literally half a circle. So it's going to make up 180 degrees. And it says the arc is, the diameter is going to be kind of like your ending points. This will also use 3 letters. So for example, in this case, I would start here. See, this is the diameter. So that's the starting and that's the ending point. So what you could do, you could go this way, but I don't have a 3rd letter that way. So I'm going to go this way. So that's going to be my semicircle. That was terrible. So my semicircle still uses 3. So I'm going to have CB. A as my arc. Okay, it's half a circle, so that makes it 180. Now, I put a star down here because later on we're going to do length of an arc. So later on, when we talk about the length of an arc, that's going to be something different. This is going to come way later, so you can still put it in your notes since we've got a whole bunch of million things in our notes today. That way you can be all organized, but we will be using this later. So this is how you find the arc length. That's different than when you're trying to find the measure of an arc. So all we're doing today and for the next couple of days is finding measures of the arc, and that has to do with the degrees. If they ask you for the length of an arc, length has to do with circumference, so it's going to be part of your circumference. So the arc length, which I'll show you one today, and you might have one in your homework, I can't remember, but it's going to be x over 360 because you're going to figure out whatever your angle is. And it's going to go over 360 because 360 is a full circle. And you're going to times it by 2 pi r because that's also part of circumference. Okay, so we won't be using that arc length much until later for sure. And then also we have a central angle. So it's an angle where the vertex is in the middle and it's formed by 2 radii. That's a fancy way to say radius, but more than one. So if you're talking about a central angle could be this one right here. So angle CRB. So the sides are made of this radius and this radius. So it's made of 2 radii. And the center, the vertex is right in the center of the circle. So we're going to use that a lot today. So tons of vocab, still got more coming, sorry. All right, next, the measure of an arc equals the measure of its central angle. So this angle, whatever the degrees are, is going to be exactly what this arc is. So the measure of angle E is going to be the same thing as the measure of arc BC. Okay? They're going to match. So that's how that'll work. If it's coming out of the center, you'll see this. Tomorrow we're going to have something different where the angle's not coming out of the center. Okay? So it only works if it's coming out of the center. Next, it says two arcs are congruent if their corresponding central angles are congruent. In other words, if that little purple angle right there, let's just make something up and say it's 100 degrees. Okay, that obviously is going to make this one 100 degrees. So what they're saying is the two arcs, so AD is also going to be 100. So if this is 100 and this is 100, same thing for those two. They're just saying that AD and BC are going to be congruent. I should put the measure there. Sorry, I forgot the M. Okay, so no angle. There's a little measure with an angle here. This is just the measure of the arc BC. That's what's going on there. Next, measure of an arc formed by two adjacent arcs is the same as the sum of the measures of the two arcs. Here's what that says, because that sounds confusing. So if you add up this one and this one, that's going to give you this arc plus this arc. That's all it's saying. So if they're asking you for arc BCD, all you would have to do is add this angle and this angle, okay? Because that's this angle and this angle. So it gives you the endpoints, which is what I want. So this 80, this angle would be this part right here, 80, and this would be the 100 right here. So you would just add up these two arcs to get 180. That's what that's saying. That's called the arc addition postulate. You're just adding arcs. Okay, two more chunks of info. Okay, in a circle or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. So here's what it's saying. For example, right here, I would have, if they told me this was regular, like this, then that would mean their corresponding arcs are congruent. So the arc that goes along with this chord is this one right here. So it goes from the starting to the stopping point. What they're saying is, since these sides are equal, their arcs, well, that's a bad one, are also equal. That's all that's saying. Okay, so again, if I had two, like let's say they gave us little marks like this, and they told me that those two were congruent. So if RS is congruent to TV, what that means is the arc for RS, so this part right here, would be equal to the arc right here. Okay. Last part. Let me get a little more room. All right, last part, diameters and chords. So for diameters and chords in a circle, if your diameter is perpendicular to a chord, so you have a diameter right here, perpendicular to a chord, it bisects it. So that means if they're perpendicular, you got a diameter perpendicular to a chord, that means it's going to cut it into two equal parts. So those two are equal. And then down here, these two would be equal as well. Okay. The other one says in a circle, two chords are congruent if and only if they are equidistant from the center. So here's what that's saying. If this chord is the same distance to the center as this chord is, that's what it's saying. So the distance from the center to the chord is going to be equal from the distance from the center to the chord in this one. If that's true, then they are, two chords are congruent. Oh, the two chords are congruent. So that means AB, in this case, is equal to RS. Okay, also they could be equidistant from the center, so you could also say that YO, the distance of YO, that's why I didn't put a segment above it, is equal to the distance of OX. So this will work both ways. Okay, so that's why I was putting both of them. So if you have these two things equal, then these two things are equal, and vice versa. So it works both ways for that. So I hope your brain didn't explode, because you know there was a ton of information. So all of that information, this is why the video is long, Now I got to apply it to some problems. So I'm not going to do every single one of these, but I did want to work out some of these problems. So they're asking me for YC right here. That means I'm going to need to find X. To do any of these, almost any of these, to do 17, 18, or 19, I have to find X. So if you notice this angle, and this angle, they make a straight line, which means they give you 180. So I need to work on all of that before doing anything. So 3X and 3X and 2X, that's going to give me 8X. Negative 3 and 15 is 12. So I just added the 3 together because it gave me a straight line, which is 180. So that's going to give me 168. So my X is 21. That's going to help me. That way I can figure out what all my angles are. So to figure out YC, I just need to know what this angle is because central angles are the same as the measure of the arc. So if that's 21 times 3 is 63 minus 3 is 60. So the measure of the arc will also be 60. Okay, BC. If I'm looking for B all the way to C, I need that 60-degree angle plus I need the 3 times X. So 3 times X is 63. So to get from B all the way to C, I need this part of the arc, which is 63, and this part of the arc, which is 60. So I had to add those two together for that one. BX, that's this one. So to find this one, I need this angle right here. So the angle marks the beginning and the end of the arc. So to figure out right here, I can just make a straight line. That's 180, and take away this 63. So if I do 180 minus the 63, that's going to give me 117. Yes. Okay. Next, so I can put that in there. Sometimes it helps to get to the next problems. Next, I need BCA. So I'm going from B to C to A. Now, what that means is I need all of these angles. So I can either figure this one out and add it with the 60 or 63, but that's not necessary. The beginning and the end are your diameter. So if it's your diameter is 180 degrees. If you did it this way, 2 times 21 is 42, 52, 57. You could have added 63, 60, and 57 to get 180, either way. Okay, lots of examples just because it's tough otherwise. All right, here we go. I got AGB is 30. So AGB is 30 right there. And then they're telling you that these are perpendicular, so you know that's a 90-degree angle. Okay, so what you can do is you can figure out what all these angles in here are. That kind of makes life a little easier. Okay, so if that's 30, this is 30. And I've got 3 angles that make this straight line. I've got the 30 and the 90, which gives you 120. That leaves me 60 here. You can also use your straight line over here and do 180 minus 30, which gives you 150. It's kind of smart to find the angles. Then you've got all the info you need, and then you can just find everything. So AB is going to be the same as its central angle, which is 30. FD, also 30. BCD, that's these 2 arcs. So you got to do the 60 and the 90. BC is 60. CDF is the 90 and 30. And FAB, that's the 150 and the 30, or you could have seen that it was the semicircle. So 180. Okay, these 2 down here are the 2 that I was telling you we're going to need the formula for. So it says I need to find DG if DGI, so if I have DGI, that's 24, and my radius is 6. So if my radius is 6, all the radii are 6. Now, if I have equal sides in a triangle, then that means this is also 24. So you can find that one little tiny missing angle in the middle if I minus the 24s. So that would be 132. So this angle right here, which I'm running, it's too little, is 132 degrees. And that is what's going to help me find my DG right there. So if I'm finding, that's how I would find if I wanted the measure. It would be 132. Here's the issue. It asks you for the length. So that's why I was saying you kind of have to watch out for that, especially when we take the unit test. So if they asked for the measure, it'd be 132. If they asked for the length, we had to go back up and do our formula, which is not on this page. It was x over 360 times 2 pi r. So X is your angle. I still had to find that angle. So I've got my 132 over 360 times 2 pi. My radius is 6. So you'd have to plug all that in to your calculator. If you don't know where pi is, you are welcome to use 3.14. So I got 132 over 360. And then I got to times it by 2. And pi is right here at the caret, but you got to use the blue button, and times 6. So if you do this, you're going to end up with about 13.8. Let me double check that. Sometimes they do weird things. Okay, just making sure. All right, so I got 13.8 for the length. So that's two different things. This is the length. This would be the measure if that's all you're looking for. Okay, same thing here. It's equilateral, so WN is 5, which makes these 5 right here. Okay, that's all it's talking about. Now, if we got an equilateral triangle, that means I just do 180 divided by 3 to get 60. So that's my angle that goes along with WN. So I got 60 over 360 times 2 pi times 5. Plug it in your calculator, good to go. Okay, so that's the length. If they asked you for the measure, it would be 60 degrees. All right, last part. So I've got SU is 20, and remember that if a radius is perpendicular to it, it cuts it in half, it bisects it. So these are 10s. I've got WY, which is 20, so these are also 10s, which means these arcs are the same. So the arcs that those two chords make are going to be equal because the chords are equal. And then WX is 45. So if they ask you for SV, already got that. UV, already got that. If I do ST, like I was saying, if these are equal, all of these are equal. So this is 45 degrees. WZ already got. YW is 20. They already get, because they wanted the arc, sorry. I'm sorry, erase. I thought it was the chord. So they want arc, YW. If they want the arc, then I have to add those two. 45 and 45 is going to give you 90. And then SU, so they ask you for arc SU, same exact thing, 45 and 45. Okay, so that's what you're going to be working on. The very last thing I want to show you are these two things. So I put this in the assignment. These are we're going to be using for the entire unit. It's like a cheat sheet. So it's kind of like a cheat sheet with all your formulas because there's going to be so many. So one of them is going to have segment rules and one of them is going to have angle rules. So these are just a whole bunch of different circles. And if you can print, it would be great. If you can't print, you can just make your own. So you can just draw your own. It's just circles. You just draw your own on a piece of paper. Okay, so to start with your segment rules, the ones that we learned today, there are 2 of them. So the ones that I want you to fill out today, this is the easiest one, this is your diameter. So from here all the way to here is your diameter. And then your radius is just the halfway point. Okay, so that's one thing I wanted you to put in there. Also, I wanted you to put that circumference is diameter times pi. Okay, so that's going to be one thing that we did today. The other thing is chords. So this little box, both of these, dyslexia is real. Sorry. There we go. So both of these circles are something that we learned about chords today. What we learned was if we have 2 equal chords like this, that wasn't exactly great. They don't look too equal, do they? You get my point though. So if you have, that looks a little better. So if you have 2 equal chords, what that is saying is you will have 2 equal arcs, okay? So however you want to put that, if you can say if chords are equal, then the arcs are congruent as well. Okay, and then the last one I wanted you to put was the one about the diameter intercepting the chord at a 90-degree angle. Okay, so all you need to know there is that if it intercepts, that means those 2 little guys right there are congruent to each other. So easiest way to put it, if diameter and chord are perpendicular, then the chord is bisected. Okay? And then, of course, if those two are equal to each other, that's going to make these two equal as well. So those are your starts. That's the two that I wanted to start for that one, for the segments. We'll add them every time I give you new notes. All right. And then the next one for the angle ones, we only learned one angle one today. So the only one that we learned today was the central angle. So if you're out of the center, this will be the same as this. They'll be equal. Okay, so I know it was long. Sorry, lots of information. I wanted to give you a bunch of examples. Good luck on today's worksheet.